Hi everybody, in this video we're going to learn about something known as throttling chatty events. Now these three words by themselves kind of make sense. When you put them together they kind of make less sense. But don't worry, in this video we'll learn all about what the problem is and how to solve them, and hopefully by the end of it what throttling chatty events means will make a whole lot of sense to you. Alright, let's get started. So here's the thing. Many of the events you use in JavaScript, like your click, or when you have a download completed, like a download progress, you're navigating from a different page, like a navigation changed event, all these events, they fire only once when they're triggered. They're pretty clean, they're pretty simple, and they're fire and forget, and you don't have to worry too much about them. These are the good events. The thing is, there are a bunch of events actually that are way too chatty. They don't just fire just once for a simple gesture, they fire many times. Like take for example the touch event or the mouse move event, for example. Each time you perform that gesture, an event is fired and the event handler for it reacts to it. And the frequency at which the reaction happens, the event gets fired, is way too high and is a problem especially for DOM updates. Now here's the reason why. The reason extremely chatty events for DOM updates are problematic is because your screen is often limited in how often it can update and paint new information. And that limit is usually 60 times a second. And these chatty events, they fire way too frequently, well beyond that 60 times a second limit. And what that means is your computer, your browser, is doing a lot of unnecessary work that ends up not really leading to anything the user sees. And that's a problem. And what we're going to look at is how to find these chatty events and throttle them so that they are more reasonable in what they do, so that you're not wasting any extra effort. Let's look at an example. So here I have Chrome. And ignore what you see on the screen here, but as I'm moving the mouse around, you'll notice that there's a lot of numbers that are updating. What these numbers represent is a count of the number of times the mouse move event, which I've hooked up on this page, is actually getting fired, and the event handler is incrementing a value. Now, as I'm moving the mouse, notice that I'm not moving the mouse, nothing happens. For moving the mouse even slightly, notice that the number is updating very frequently. And the place I really want to focus on is not really what you're seeing on screen, because that is pegged at 60 times a second, but a console, which is right below it where the same number is displayed. Notice how frequently these numbers are changing with each time I'm moving the mouse cursor on the screen. Now, this is an example of a very chatty event, which is mouse move, and it causing updates that are often not all being displayed on the screen. Now, this updating a number is a pretty lightweight operation, but you can imagine doing some tasks that are a little bit more CPU intensive or a little bit more resource hungry, where you don't want to waste a lot of effort, especially when you're going to be doing something very frequently. So there are very many ways you can solve this. And one of the most common ways you'll see people using is a timer. And what we're going to do is a variation of that. We're going to throttle them using my favorite timer, especially for items relating to updating the DOM, requestAnimationFrame. So for this, we're going to look at some code. And so what I'm using is the Atom code editor, and here's the code that currently makes our application do what it's doing. So first of all, there's really nothing going on this page. We have some styles, we're going to minimize, not really needed. We have some HTML, and all this HTML does is display the element that it's going to be hosting our counter. The interesting stuff really happens in our code, where we have the add event listener and the mouse move event we're listening for, and the event handler is called deal with scrolling. And the thing is, the deal with scrolling event handler is being called each time mouse move happens, and inside the deal with scrolling event handler, we have nothing crazy going on. We're just incrementing a counter variable, which we then use to display on screen and display on our log. And the problem is that because mouse move fires so rapidly, this deal with scrolling event handler is called way too much, way too chatty. And that goes back to our problem of we want to throttle this, we want to slow it down. And the way we're going to slow it down is by using requestAnimationFrame. So what I'm going to do is this. I'm going to copy and paste some code, and we'll make sure it all works. And then we'll talk about exactly how it works and why it works the way it does. So I don't think you want to see me typing in a lot of code. I'm going to paste something in here, and we'll look at exactly what's going on. So what I've done here is I pasted a chunk of code, and I'm going to replace the deal with scrolling event handler with throttle event, which is the event handler that's called. And now here's the thing. The way this event works is that at each time a mouse move event is fired, the throttle event handler is called. And what I'm doing is the first thing I do is I check this boolean saying if is firing is false. In this case, by default it is. Create a requestAnimationFrame call, and at that moment call whatever code we want to execute as part of the event handler running initially, in which case, our case was deal with mouse move. So each time the throttle event is called, we tell requestAnimation to call the deal with mouse move event. deal with mousemove function, which is our code we had earlier for updating the counter, updating the console, and doing all the stuff that was needed to display things on screen. And the moment I do that, I set the isFiring variable to false to indicate that we're no longer firing the event. And then once this event has cleared, I set isFiring is true again. In this way, I'm basically creating this artificial lock and unlock mechanism, something you might have seen in your programming classes or just in general in the past, where I'm creating this, artificial delay and using requestAnimationFrame function as an executor of my will, which in this case is dealing with all the event handling stuff that was normally directly handled by the event handler before we actually throttled it. So once I've done this, let me go back to our code, just refresh what happens when I refresh the page. And notice that once I'm doing this, notice that our numbers are still updating, and it might be a little hard to see, you might need to go back to the video to see this, but no matter how fast I'm moving the mouse around, you'll notice that the numbers, both in the console and what you're seeing on screen, aren't really updating any faster than 60 times a second. And that's exactly what we're kind of looking for, is that we don't want to go any faster than 60 times a second, because that kind of defeats the purpose of all the DOM optimizations that your browser does. And we don't want to go slower as well, because we are dealing with the DOM. But you can imagine, if you want to go from something from requestAnimationFrame to something even slower, like a set interval or a set timeout. But that's something I'm going to leave as an exercise for you to deal with. So there you have it, a quick overview of the problem, where you have some events that are really chatty, which is not a problem by itself, but it is a problem when they're doing DOM updates, because at that point your browser and your system is just doing a lot of unnecessary work that is never going to benefit anybody, I think displayed on screen. So what's the point in doing all this work? So in our solution, we throttled it by pegging all these event handling to the requestAnimationFrame method, which is all about tying everything to your screen's refresh rate, 60 times a second. But you can use set interval and set timeout or any other mechanism you might want to use to make this happen. So if you found this useful, go to Krupp.com, where you find a bunch of articles related to this and other topics. And if you need help, the easiest way is to post in the forums at forum@Krupp.com, where I or a bunch of other people who care a lot about events and performance and know totally what throttling events means can help you out. And of course, you can also ping me on Twitter, Facebook, YouTube. I'm all over the place. Just find me. You'll be able to get in contact with me, and I'll get back to you soon. And of course, if you like this, please tell your friends and enemies. And of course, hit subscribe. The more subscriber count goes up, the more high fives I get in this feed from random strangers, which is a good feeling. And of course, follow me on Twitter and Facebook for similar bite-sized updates on other new things I'm working on or cool things I found on the net. I follow some pretty interesting people, so by following me, you might be indirectly benefiting from the stuff that I discover. And of course, buy a book if that's something that you're interested in. If you don't like reading things on screen but want to have a physical book, or even a Kindle edition, which is technically a screen but a more portable screen, you can check out my book, which is JavaScript Absolute Beginner's Guide. It's my latest writing on how to make JavaScript as fun to learn, especially if you're a beginner. So definitely check that out. And of course, there are a lot of cool books by other authors out there as well. So I won't hold it against you if you tend to buy someone else's book, like anything by John Duckett. All right, guys. Talk to you later.